Hi everyone. Let's say we have a non-ideal battery. A non-ideal battery means a battery that has an internal resistance, small r, and the EMF. Let's say the EMF is 12 volts. When this battery is connected to a load, like to a resistor R, 100 ohms, then the voltage across this battery is measured. The voltage across the battery is measured, and let's say we get a voltage of 11.5. So there is a voltage drop inside that battery due to its internal resistance. The question is, how can I find the value of this internal resistance? And usually this internal resistance is going to be small in value. So that's how we solve the problem. The voltage across the battery, so again that's the battery. If you want to imagine it, the battery is from here till here. Okay, that's the battery, like that. Okay, here I have the positive, here I have the plus, and here is the minus. So, V across the battery, it's the EMF, but I have a voltage drop across the resistor, the internal resistance. It becomes E minus Ri. So we highlight that equation. That's the first formula. The voltage is 11.5 equal to the EMF, which is 12, minus R multiplied by I. So to find small r, the internal resistance of the non-ideal battery, we need the current I. How to find I? Again, if you look carefully at the circuit, it's clear that the 11.5, it's also the voltage across the load resistor, the 100 ohm resistor. So the current I, this current I, is simply V over capital R. So I is 11.5 over 100. And what will be the value of this current? 11.5 divided by 100. So it's going to be 0.115 amperes. So we substitute this value that we get here. So we substitute that value in the equation. We'll have 11.5 is equal to 12 minus a small r multiplied by 0.115. Then r will be 11.5 minus 12, or if you want, okay, that's fine, 11.5 minus 12 over minus 0.115, like that. Or if you want to write the equation of small r, it's simply equal to E minus V over I. Okay, that's another formula to find, a direct formula, in other words, to find small r. So first we find I using Ohm's law. First we find I, that's step number 1. After you find I, step number 2, use this formula to find the internal resistance. Now we substitute. R is equal to the EMF, which is 12 minus 11.5 over the current that we got, 0.115. Okay, so I'm gonna erase this part here so that you don't get confused. Okay, we do the math. So the internal resistance will be 12 minus 11.5, which is 0.5 over 0.115. So 0.5 over 0.5 divided by 0.115. Let's use the calculator here. You will get around 4.35 ohms. Or in other words, it's around 4 ohms, something like that. Okay, 4 ohms. So this is how we find the internal resistance of a non-ideal battery. Thank you for watching.